Good day, my name is Kishen Mewalall, student number 55896758. This presentation summarizes my GEO3701 desktop study for the proposed small dam and reservoir in the GA Matipa Ragopola area of Limpopo. I will cover the site setting, climate and topography, map geology, possible ground risks, the proposed investigation work, and my main conclusions and recommendations. The project is a desktop study, so I did not treat the results as final design information. The brief gave 2 points, point A for the dam wall center, point B for the reservoir basin. I used those points to check the satellite setting, terrain, and mapped geology. The dam is intended for community water supply and small-scale irrigation, so the ground conditions are important for both safety and long-term performance. Next slide. The climate and terrain were important to the interpretation. From the WINET map, I adopted the N and N value of 3 because this is below 5. Chemical weathering is expected to be important, especially where feldspar is present in the Arcos and feldspathic quartzite. Google Earth also showed that point A is much higher than point B by about 85 to 87 meters, call it between 85 and 90 meters. This is unusual, so a proper topographic survey is my first recommendation. Let me just go. For problem soils, the main message is that the map does not prove the material behavior, but it does show where the risks are likely. Around point B, alluvium and scree may be loose, variable or permeable. Fine material could be dispersive or erodible, and some deposits may compress or collapse when wet or when wetted. At point A, weathering of feldspar-bearing rocks may produce weaker residual soil. These risks must be checked. These risks must be checked before design. At the dam wall, the intact quartzite may be strong, but the foundation will behave as a rock mass. That is why discontinuities are important. The likely features are joints, bedding planes, possible shear zones, lithological contacts, and local cleavage or fabric. The investigation must record orientation, spacing, persistence, roughness, aperture, infill, and water. These features can form seepage paths, unstable blocks, or sliding surfaces in the abutments. My proposed investigation starts with a site walkover, followed by boreholes along the dam wall and trial pits in the reservoir basin. The boreholes will confirm the depth to competent rock, the weathering profile, and the condition of discontinuities. The trial pits will check the alluvium and scree. The testing program then covers classification, compaction, permeability, shear strength, collapse, and dispersivity for soils, as well as strength and durability tests for rock. In conclusion, the desktop study does not reject the site. Point A may provide a suitable foundation if competent rock is shallow, but weathering and discontinuities must be checked. Point B has the greater uncertainty because alluvium and scree may be permeable, compressible, or erodible. My main recommendation is to complete the topographic survey and geotechnical investigation first, then review foundation treatment, seepage control, environmental authorizations, and water use requirements before any final design. Thank you.